Okay, so go to the notes that you guys used, their topic or lesson 1.5, analyzing the graphs of functions, and we are going to finish those up today. Now, today's lesson needs a graphing calculator. I included a link in your assignment. Here it is. Goes to this page, and over the summer, they are like when the coronavirus first hit, we were on quarantine, they allowed students to do free trials. Right now, what it says is free trial for teachers, so you can try it. So don't do this first one. TI Inspire is not what we use. So you can do this one, the 9-day trial of the TI Plus Emulator if you want to see if it works. If you have a school Chromebook, then you should already have the Chromebook app on there. You just have to find it by searching for it. If you have your own Chromebook, you can do a free trial here. So hopefully you can find something you can use today. If not, I am going to give you guys some time tomorrow in class to use my calculators. All right, so when we're talking about relative maximum and relative minimum values, I kind of, after I started teaching calculus, changed the way that I define this. So I'm defining it now in a way that will help you if you decide to take calculus, which is a really good class. A relative maximum occurs when a function changes from increasing to decreasing. So you can see on this function, as we here are going right here, we're increasing, and then it changes over to decreasing. At that point where it changes over, that is where the relative maximum occurs. All right, a relative minimum occurs when the function changes from decreasing to increasing. All right, and you can see that we'll just go back over this. Here we are decreasing, and then we change to increasing. That point where it changes is a relative minimum. Now, there can be more than one relative minimum value in a function and more than one relative maximum value in a function. There doesn't have to be one or the other either. Just depends on the function. So the relative maximum and minimum are just lower or higher than the points that are relative to them, the points that are around them. All right, and then we're going to define our relative maxima and minima as ordered pairs. And these are the steps you go through to do it in the calculator. All right, so if you have your own calculator or you've downloaded that emulator, follow along with the steps. If not, you can just watch me do it, and then hopefully you'll remember when you have the steps here, when you go to do it on your own. All right, so our first step is to graph the function. So I'm going to go to my emulator. To graph a function, you go to y equals. Okay, so there's the function. All right, step 2 says to type second and then trace to get to the calculate menu. Now I'm going to change my window slightly because I can't see the top right there. So I'm going to go to window and just make it a little bit taller on the Y. There we go. I like to be able to see it when I'm finding it. All right, so to find the maximum and minimum, we're going to do second and then trace. This takes you to the calc menu. Now, if we want to choose a minimum, we choose number 3. If we want to choose a maximum, we'll choose number 4. So let's just go ahead and do the minimum first. All right, you get this little flashing cursor. So what we'll do is move that cursor, because at the bottom it says left bound. So we're going to move that cursor to the left side of our minimum. So there's our minimum about right there. So move so we know for sure we're on the left side, and then hit enter. All right, and then I'm gonna hit the right arrow to move, so I'm definitely on the right side, and hit enter. So these newer calculators give you little vertical lines, so that minimum value should be in between those vertical lines. And these two arrows should be pointing towards each other with some space in between. All right, guess doesn't matter at all, so we just hit enter one more time. And there's our minimum. All right, so let's just go ahead and go to 3 decimal places on our minimum. So negative 3.333 and negative 6.159. All right, our maximum, we're gonna do pretty much the same thing, just a different button. So second trace, for maximum, we choose number 4. All right, there's our little flashing cursor right there. So we're gonna move it closer to the maximum, but where this is left bound, we have to stay on the left side of it. Hit enter, hit the right arrow, move to the right side of it, hit enter, and then enter one more time. All right, now you may have got something slightly different than I did. That 1.3819e to the negative 6, that e is scientific notation. So it means this number times 10 raised to the negative 6, or 0.0000138. So when you see this with the e and a negative number that's 6 or 5 or 7 or 8, that really means 0. And there's some kind of glitch in the calculator. It doesn't give you 0, and sometimes it does. But in this case, we don't get, the calculator doesn't give you exactly 0, but what it gives you means 0. All right, so that was the first part of the directions, relative minimum and relative maximum values. The second part is to find the zeros. And we can use our calculator to do that as well. All right, so to find the zeros, we're going to do second trace again to get to the calculate menu, and to calculate a 0, you choose number 2. All right, now zeros are where the function's equal to 0 or the x-intercepts. So this one has 3. So I'm going to take my little flashing cursor. I'm just going to start with the one on the left. I'm going to move it close to it, but I need to be on the left side of it. So here's the 0. I'm on the left side. Hit enter. Cross over the x-axis, hitting the right arrow key. Hit enter. And remember, if you have one of these newer calculators, you can see the 2 lines. The 0 should be in between the 2 lines. And then hit enter one more time, and that's your 0. And you don't. On the zeros, the y's, you don't have to give them as an ordered pair if you don't want to. The y is going to be 0 at the 0. So we'll go to 3 decimal places again. So that was negative 4.372. All right, we want another 0. There's 2 more to find. So second trace 2. I need to move close to it, but I do need to stay on the left side of it, so that's good right there. Hit the right arrow to cross over the axis, and then hit enter again, so we have a 0 at negative 2. Okay, and then one more. Second trace 0. We want to move close to it, but we do want to stay on the left side. Hit enter, hit the right arrow, cross over the axis, hit enter, and then enter again. 1.372. Those are our zeros. All right, and then this last part, we're going to determine the open intervals on which the function is increasing, decreasing, or instead of neither, let's just say constant. Okay. So just a reminder, the maximum and minimum are where the function changes from increasing to decreasing or from decreasing to increasing. So when we're giving these x values where we're increasing or decreasing and so on, the x values we need, we found here and there. All right. Oh, sorry. I was on the wrong page. All right, let me say that again. So we're finding where the function's increasing, decreasing, or constant. And like we said at the beginning, the function changes over from increasing to decreasing at the maximum and changes from decreasing to increasing at the minimum. So we're going to need the x values from our maximum and our minimum to get these intervals. All right, so I can tell from my function that we're increasing from this point to this point. All right, this point to this point. Now we do not care about the y's at all. The y's do not matter. We care about the x's. So the x, where this function starts increasing, is the x part of that minimum. And the x part of that minimum we found was negative 3.333. And then the x part of this maximum is where the function stops increasing, and that one was 0. Whoops. All right, so these are x's, both x's, x values. All right, let's do the decreasing. Okay, so when the function starts being a function, as far as you can go to the left for decreasing until we get to this minimum. So that's going to be as far as you can go to the left is negative infinity until we get to that x part of the minimum, which is negative 3.333. All right, and then at this maximum, it starts decreasing on the other side of the maximum, decreasing forever to the right. So forever to the right is going to be positive infinity. So we're going from negative infinity to negative 3.333, and then we pick back up at 0 and increase forever to the right. All right, now these last parts we don't need a calculator to do. So number 8 is no calculator. This is determine if a function is even, odd, or neither. So for an even function, f of negative x is the same as f of x. So that means we plug negative x in for x and you get the exact same function. Now if you were to look at a graph, this graph would be symmetric to the y-axis. So it would look something like this. All right. Odd functions, when you plug negative x in for x, you get the complete opposite. So plug negative x in for x, and you get the opposite sign for every term. All right, and then on the graph, this graph is symmetric about the origin if it's odd. Now that's a little bit harder to see, but symmetric about the origin looks something like that. There's a whole lot of functions that are neither. Even in odd functions are special functions. There's a whole lot of functions that aren't necessarily special. So the neither functions, when you plug negative x in for x, some signs will change. And some will not. All right, so let's do a couple of these. So when we're determining if a function is even, odd, or neither, we're going to find f of negative x, which means we just make all of the x's negative x's. All right, and then when you have a negative and you raise it to an even power, it becomes a positive. So negative x to the fourth is going to be positive x to the fourth, because a negative times a negative times a negative times a negative is a positive. All right, and then same thing on this one. The negative x to the second is the same as x to the second, so that sign just came down. So if you look at this compared to the original, it's the exact same function. That means this is an even function. All right, so nothing changed, is an even function. All right, let's look at b. We're going to put negative x in for x. All right, now when we take a negative and we raise it to an odd power, a negative times a negative times a negative, that is a negative. So 2 times negative x to the third is negative 2x to the third. And then 3 times negative x is minus 3x. Right? And then when you look back at this one compared to the original, every sign changed. So this positive 2 became a negative 2. This positive 3 became a negative 3. That's what it looks like when you have an odd function. Now, don't be super surprised if you get a bunch of neithers. There are a bunch of neithers. Whenever some signs change and some don't, you have a neither. Okay, so your assignment is on page 56 through 58. I want you guys to do 1, 2, 5, 6, 25A, 30A, 50, 52, 54, 58, 60, 65, and 72 through 82.